Welcome to the Deep Dive. We're the shortcut to getting you well-informed, fast, pulling the key ideas from source material. Today, we're digging into CATIA for surface modeling, specifically mastering advanced styling techniques. Our main source is work by Priya at My Assignment Solution, published this year, 2025, and our mission: to figure out why CATIA surface modeling is, well, so powerful, how it's different, and where it makes an impact.
Yeah, and maybe to kick things off, it's really important to draw a line between surface modeling and solid modeling. They sound similar, but they're quite different beasts.
Okay.
Think of solid modeling like building with digital blocks. You're creating things with volume, with mass, like an engine part, defined inside and out.
Great, solid.
Exactly. Surface modeling, that's more like sculpting with a thin sheet. It's all about the skin, the complex curves, the look, the feel. Think freeform shapes, really aesthetic designs. You're not initially worried about what's inside the shape.
Ah, okay, so it's the aesthetics and the complex shapes.
Precisely. It's indispensable for that advanced styling, for really pushing design innovation, especially where looks matter.
Okay, so building on that difference, what makes CATIA's approach to surface modeling so, well, powerful? What's its edge?
Well, the source highlights a few key things. First, it really frees up designers, allows for true freeform creation.
Freeform, like organic shapes.
Exactly. Organic, flowing, aerodynamic shapes, think sports cars, aircraft fuselages, that kind of thing. Stuff that's hard to define with simple geometry. And crucially, it provides extremely precise tools. These are needed to generate what we call Class A surfaces.
Class A surfaces, that sounds important.
Oh, it is, especially in automotive. These aren't just good enough surfaces. They have to be perfect. Like mirror finish perfect. Even a microscopic ripple can totally ruin the look when light hits it on a car body. It affects the perceived quality, you know?
Wow, okay, that level of detail.
Definitely. And CATIA gives you the tools to analyze that. Advanced visualization, checking curves, checking surfaces, scrutinizing every reflection. And it lets you hit that high aesthetic bar without messing up the engineering underneath. That's a constant balance.
Okay, that makes sense. So, given it can do all this, how? What are the actual tools inside CATIA that let designers pull this off?
Right. There are specific environments or workbenches. A big one is generative shape design, GSD, they call it.
GSD.
Yeah, that's where you build up complex geometry from basics, curves, sweeps, lofts, blends, knitting surfaces together piece by piece. It's quite foundational.
Building it up bit by bit.
Exactly. Then there's the FreeStyle workbench. That's geared much more towards the aesthetic side, the industrial design. More intuitive, perhaps more sculptural.
So one's foundational, one's more artsy.
Sort of, yeah. You also have wireframe and surface design. That's critical for getting the detailed, accurate surfaces laid out before you might turn them into a solid for manufacturing.
Right, defining the skeleton first.
You can think of it like that. And then crucially, you have the surface analysis tools. These are vital for checking the quality.
Quality checks, like smoothness.
Smoothness, yes, but also continuity. This is a big one. We talk about G0, G1, G2 continuity.
G0, G1, G2. What's the difference there?
Okay, think of it like this. G0 is just touching. Two surfaces meet at an edge. Point connection.
Okay.
G1 means they touch and they're tangents. They flow in the same direction at the meeting point, like two road segments meeting smoothly. No kink.
Got it. Smoother.
Right. But G2, that's tangency plus the curvature is the same. The rate of change of the angle is identical. That's what gives you that perfectly seamless, almost invisible blend. No sudden change in how light reflects. That's the goal for Class A.
Okay. That G2 is the real target for those perfect surfaces.
Yeah.
I get it. So with this level of precision and focus on aesthetics, where do we actually see this in action in the real world?
Oh, it's all over the place, really. Automotive design is probably the most obvious. Sculpting car bodies, getting the aerodynamics right, achieving that brand look. Huge user.
Makes sense. Cars need to look good.
Absolutely. Then aerospace. Designing wings, fuselages. Anywhere, aerodynamics are critical and the surfaces are complex. Performance depends on it.
Right. Performance and flow.
Yep. And consumer products. Think about sleek electronics, kitchen appliances, even stylish furniture. Those elegant curves and ergonomic shapes. Often CATIA surface modeling.
I hadn't thought as much about appliances, but yeah, the design matters there too.
It really does. And maybe a bit less obvious, architecture. Especially modern avant-garde buildings with those flowing organic facades or structures. CATIA helps create those complex forms.
Even buildings.
Wow.
Wow. Okay. Are there places it's less common than you might think?
Well, maybe in areas like heavy industrial machinery. Function often trumps perfect Class A aesthetics there. Robustness is key, so simpler solid modeling might be enough. The need for that G2 perfection isn't always there.
Okay, that distinction makes sense. So if someone listening is intrigued, maybe wants to explore this themselves, what are the pro tips for actually mastering surface modeling in CATIA? Any advice?
Yeah, the source gives some good pointers. Definitely start simple. Master basic sketches and curves before you jump into complex freeform stuff. Get the fundamentals down,
Walk before you run.
pretty much. And really get good at using multi-section surfaces. That technique is key for blending different complex shapes together smoothly. It's a workhorse tool.
Multi-section surfaces. Got it.
And this is critical. Always check your surface continuity. Constantly analyze. Especially aiming for that G2 curvature if you want Class A quality. You have to be rigorous about it.
Check, check, and check again.
You bet.
Uh,
Another really valuable skill is practicing reverse engineering workflows.
Reverse engineering, like taking something apart.
Sort of, but digitally.
Yeah.
You might take a 3D scan of a physical object, import that point cloud or mesh into CATIA, and then build clean, precise surfaces over it.
Recreating a real object digitally.
Exactly. It's great for redesign, analysis, or just capturing complex existing shapes accurately. And finally, remember, it's often about combining surface and solid modeling. You use surfacing for the complex external shapes, the aesthetics, and then you might integrate that with solid modeling for the functional, structural parts to get a complete manufacturable design.
So it's not always one or the other, but using both together.
Often, yes. That's where the real power lies for complex product design.
Okay, so wrapping this up, what's the big takeaway here? From Priya's insights, it feels like CATIA surface modeling isn't just about making things look nice. It seems more fundamental, like it's about bridging imagination and reality with incredible precision.
That sums it up really well. It's about bringing complex ideas to life accurately and beautifully, mastering these tools. It genuinely can take your designs to the next level. Doesn't matter if you're an engineer chasing aerodynamic perfection, an architect creating fluid buildings, or a product designer aiming for that perfect curve. It unlocks possibilities.
So think about this. How much the designed world around you, that curve on a car, the sweep of a plane's wing, relies on this careful blend of, well, art and engineering. Where else do you see that kind of seamless fusion happening?